Well, I was about to start the video segment, which carried some of the analytical aspects of this particular problem. Then I realized that the numbers that I showed you on the graph somehow they didn't look right, and it turns out that I made a mistake in the formulas that I inputted in there. And now that I have the opportunity, or at least I can fix that issue, there are some other things that I want to bring it to your attention to. First of all, notice that's right here. This formula was right here, and look at this thing that I wrote down. I said that 180 degrees per 1 radian. That's wrong. 180 degrees is actually 3.14 radians, not 1 radian. So let me go ahead, double click on this, and fix that. So there is my one, instead of 1 radian, it should be 3.14. Okay, 15. That's pi basically, radians. So that's first thing. Same thing down here. It's the same mistake. It's instead of 180 degrees being 1 radian, it's 3.1415. Okay. Now we're going to run this thing again. Simulation with command, reset it, activate sensors. I want accelerations. Where are the acceleration? X component of angular acceleration, Y component of angular acceleration, Z component needs to be on. So we're going to move this thing here. And just to make sure that this goes a little bit faster, why don't I change this thing to, instead of 400, let me make it, I don't know, maybe 300 steps. Okay, and let's run it. What did I do? Let me try it again. Oh, I think I pressed that by mistake. So let's see, activate sensor. These are, I checked already. Okay, so very good. And let's play it. There we are. This is a little bit faster. But be careful, if you make it too fast, then there may be some jagged behavior as you plot the curve. Okay. Okay, I think this is done. So let's go ahead and graph it. All right, notice that if you select, for example, put the cursor there and select the yellow one, it shows you that the yellow one is the speed or acceleration, x component of acceleration, and the green one is the y component of acceleration, and of course the red one is the z component of acceleration. Actually, I noticed that by mistake I selected angular speed instead of acceleration. My mistake. Close this. Go back here. It's not these things that I want to do. It's the acceleration. It's these things. All right, good. Rewind. Make sure you clear your history. And unfortunately, you're going to run this again. By the way, notice that while this is running, I have gone to Tools Options and I changed my angular acceleration unit to radians per second, square second, per square second, okay? For example, your speed, your unit of speed, the default is turn per minute or RPM, but acceleration, I don't know I don't know whether it's default or not, but if not, then you go and change it. For example, it may be radians per meter per yeah, probably you can also do a degree per second squared. But anyway, it's the right unit. That's what I want. Okay. Now why do I have four of them? Okay, no, three of them. This one I didn't check. Okay, fine. Just give it a minute. There we are. It finished. Graphics. All right. So notice that the yellow one is x component of acceleration, and it is cosine, negative cosine. This is negative cosine. You will see in the last video segment that actually it is negative cosine and 12.5. Originally, when I looked at the graph that I showed you in the first video segment, that number was around 120, 130. But that's because the factor of 3.14 twice was not included. So it's whatever you had before divided by 3.14 squared, and that's going to give you 12.5. This is the angular acceleration, the other component, and it's also same value, but this is sine. This last one, you might say, well, what the heck? Why does it look like that? Actually, these are all zero because look, these are all pretty much zero, except because of the fact that I used the fewer steps. Then there's a big jump here. Okay, so this red one is supposed to be all zero. Okay. And if these jumps are, it happens, you must have to sort it out. You must realize that these are not physical entities. Okay, now by the way, if things don't fit here, the way to fix it, and now look, I can't see what the rest of this thing is saying. So you use the zoom in and zoom out from down here, or the middle mouse button and zoom in, zoom out, zoom in, zoom out. And of course, pan is same thing with the pan. If you want to pan it, let me see, you can use this for example, or the yeah. Anyway, now what is the other thing that I wanted to show you? Let me close this. Actually, let me return this thing to the reset position. Now, if you go here, I told you that because my units of acceleration was correct, instead of doing it like that, 2 times 1 radians divided by 1 second, I can say 2 rad underscore second. Now this stuff has to be here because units have to match. Left side is degrees, right side must be degrees. And now that is the case. But what I'm saying is that I did not have to write this 2 times 1 radians divided by 1 second. 2 rad per second. And same thing with the other one. When I was doing the first one, I told you that there are other ways of doing these things as far as writing it is concerned. And I'm showing you now what the story is. Rad per second. Okay. Notice that it's not complaining. It's not complaining as far as unit being inhomogeneous, etc. The other thing I want to show you is I want to plot these things versus not time, but versus, for example, versus the angle of the rod. So I'm going to create 3 plots: x component of acceleration of that rod versus its angle, y component versus the angle, and z component versus the angle. Of course, z component we know is going to be 0. But anyway, I want to show you how to do things like this. Okay, so you go here, you go simulation with laws, activate sensor. Okay, now see here, it says options. So you click on the options. It says, do you want stuff versus time, or do you want to customize it? No, I want to customize. So add. It says, okay, your first curve, what do you want it to be? I want x component of acceleration, not x angular acceleration, right there, versus angle. Angle, and this is the angle of the rod. See that joint one, revolute one? So it's going to give me a plot of x component of acceleration, angular acceleration, versus the location. location of the angle. I say, okay. Well, I want to do another one, add. This time, y component of the angular acceleration versus angle, not versus time, right here. Here's the angle. Third one, add z component of the angular acceleration versus angle. And we say, okay. By the way, the unit of angle is going to be, of course, is going to be degrees, right? Because I didn't change it, my angles are in degrees. That's okay, there's no problem. And I say, okay, close it, and I'll play it, just like before. Okay, what we have to do is I forgot to say generate this thing, because in order to get those plots, I also need this angle to be activated so that it's recorded along with these other three so they can be plotted. Don't forget to activate this angle. In other words, select it. And then you play. Is history clear? Yes, history is clear. Very good. And then play it. I think I was going to include this stuff in the last video segment, the third one that I'm going to do, which includes the analytical approach to this problem. But it's a good opportunity. I did it here, and so the other one is just going to be the analytical result. It wasn't a total waste of time, because that mistake allowed me to separate some of the items and take it away from last segment and include it in here. Almost there. So you can generate anything versus anything else as long as you have requested that information in the sensors. Okay. Remember, the x component, y component, z component acceleration, I asked for it, it said yes, and the angle that I want to be plotted against must also be requested. Okay, so let's see now. When you say graph now, okay, when you say graph, it shows you, look, it shows you the acceleration on this axis and the angle on the vertical axis. And here is curve 2 and here is curve 3. The only thing is that I have my axis wrong. Okay, so I wanted the horizontal axis to be the angle. So let's do it again. Let's go back here, and then on their options, curve 1, edit. Yeah, I want the horizontal axis to be the angle and the vertical axis to be x component of the acceleration. I selected them, yeah, bad way. Go to curve 2, edit, the horizontal axis to be angle location and the vertical to be y component of angular acceleration. And the same thing with the third one, edit, this one to be angle and this one to be the z component of angular acceleration. Okay, so say all right, we rewound, make sure you clear your history, because otherwise it overwrites the other stuff, and then we run it. So in that little dialog box that you get, the first line is the x component, x label or x axis, and the second one is the y axis, whatever you're plotting. Okay, the plots that I got were not wrong. It's just that it was, the axis was not in the orientation that I wanted. I think it was useful to learn how do you plot something against something else instead of versus time. Those are customized plots that you choose according to what you're looking for. We're almost at the end. Give it one few seconds. Okay, we're almost at 2 seconds, the end of the time. So you look at the graphics. Notice that you have three tabs here, three graph one. This was the X component of acceleration, which is actually a cosine. You'll see in the next video segment, it is a cosine. The Y component is a gain sine. The magnitude of these, the height of it is 12. Actually, this 12 is not by chance. It's the product of the velocity of the angular velocity of the bar and the angular velocity of the turntable. 6 times 2 is 12. Okay, and the last one, it looks weird, but look, these are all zero, except these are artifacts because of the choice of the step size. As a matter of fact, what I'm going to do is I'm going to rewind, clear this. Let me close that. Clear the history. And what I'm going to do, I'm going to choose, for example, 500 instead. It will affect that last plot. That last plot will be affected to some extent. Those jumps, you cannot get rid of it, but completely, but you may not be able to get rid of it completely. But this is going to take maybe a couple of minutes because it is 500 steps, obviously, so we can see it's going to go slower. Okay, and then we're going to look at the three plots. Unfortunately, I don't know of a way to print those plots. You can always capture the screen. You can't capture screen actually, or you can take the data that's generated and export it as an Excel file, and then add whatever you want to it. See that this file? See right there, right there. This allows you to export it into a file. No, I don't want to do that. There is a price that you pay here by taking more steps. The graph may improve, but obviously this is going to get slowed down considerably. I don't think there will be any major changes in the first and second plot, second curve, but the third one may, it may affect the size of those jumps. Those jumps are not physical. As soon as I finish this video segment, I'm going to post the first two, and then the third one, which is the analytical approach to this problem, I will present it to you later, make a video and present it to you later tonight. We'll be done shortly. Okay. We're almost at the end. Very frequently, people, when rewind things, people forget to clear the history. That's why they get graph on top of a graph on top of the graph, and they begin to wonder what these things are for. Okay, so let's look at our graphic. Click on the graphics button here. Three graphs. Okay, this is the first one. As I said, it didn't change much. This one didn't change any. Yeah, look at what happened here. Look at the scale. Just look at the scale. The scale is 0.03. This height is 0.03 rad per second squared. Before it was, I don't know, 8 or 9. So for all practical purposes, these are all zero. The scale changed. When you change the scale, when we change the number of steps, it's more accurate, and you can't consider the jump, but you can see that for practical purposes, this jump, the height of the jump is zero. Okay, that'll take care of this. See you later at the third segment.